G'day everyone. Today I'll take you through the process of collecting imagery, annotating imagery, and uploading it to the WeedAI platform. So it should be the entire pipeline. So the WeedAI platform, it's something we built a few years back, and it's all about the standardized sharing of annotated weeds imagery, collected in a whole range of different ways. But the most important thing is that you report how the data has been collected, so other people can sift through it and search through it in the future, so they can either test out their own algorithms or build their own algorithms, or perhaps fill in gaps in their data sets that don't exist. So it's a great resource if you're starting out and you want to test on some existing data sets, or if you want to contribute to it and help build a more open source weed identification community. So to take you quickly through it, the platform is effectively, you can group by different crops or different annotated weeds or annotated crops, different crop growth stages, different artificial lighting, location, tasks, all sorts of things. And for example, if we want to look for everything that's been annotated with, let's go with Amaranthus palmeri or Parma amaranth. If we click on that, then it should sift through all the data sets that we have and show all the images in the data sets that do have Parma amaranth in them. And so you can keep scrolling through. There are 2,185 images with Parma for this example. And you can also see different growth stages of Parma amaranth. So this is Parma amaranth at BBCH 51 to 59. So it's a much older Parma amaranth, but also some younger ones in there as well. That's something I collected a while ago. This data set is another data set from another group, multiple weed species detection. And we can click through to this data set if that's one we want to download. It'll give us some examples. It shows us a bit about the data set and whose it's from. This one was collected at Cornell, and also some annotation statistics. So the number of images that were collected for each of these species and the number of bounding boxes or examples of each weed within that class. And what's really interesting is we've included some ag context, is what we call it, or different agricultural specific metadata that is related to the annotation. So this is a fallow environment. There's no crop growth stage. Soil color is gray. Cereal surface cover, so that's the stubble or something on the soil surface, and what percentage that is, plus the location. Then the photography, and so things like camera, height, field of view, different lighting, and what the weather was when the images were collected. And they're also linked to a publication. So if you have some published data and would like to upload it, you're certainly more than welcome as well. So that's the end result of today's tutorial. I'll be showing you how to upload your own data set, and I'll be doing it with some wild radish data that we'll annotate. And this is the platform to do it on. So we'll export it through Roboflow. We'll use Roboflow, an open source platform, to annotate in a whole range of formats and export them. And then we can upload it to WeedAI more, I guess, in a more user-friendly way, because Roboflow picks up on some of the dataset issues that WeedAI might encounter. But certainly check WeedAI out if you're getting started in this domain. But the first, I guess, port of call, or the whole first thing in this pipeline, is the actual image collection itself. And collecting weeds imagery really depends on your end use case. So if your end use case is spot spraying on a large sprayer with particular machine vision cameras, then you probably want to go ahead and collect your data with those machine vision cameras, or you want to generally collect image data with the end use in mind. But if you're just doing research, or you have an interest in a project, it's very possible to go out and collect image data with your phone or with whatever is available to you. And I think that is a very low barrier to entry way of getting started in this space. And so what we've done at the International Weed Recognition Consortium is put together some protocols to help you get started. So this is a global initiative led by Muthu Kumar Bhagavathanan at the Texas A&M University, and hoping to build this community around weed recognition. So you can find a whole range of different things up here, like current projects or upcoming events. But if you go to the protocol tab, you'll find a couple of different protocols here that might be relevant. There's one that the US group has been using with machine vision cameras and DSLRs, I should say. So they're digital handheld cameras. But this one I've developed is about mobile devices. So using mobile phones to collect images in field. And it's been my go-to because it's really easy. It's very if you're in a field, you don't have a DSLR, you can just pull out your phone and collect 100, 500 images within half an hour. It doesn't take too much effort. The way to do it though is in a consistent way. So try and, I guess, minimize the variation if you'd like to have a data set that performs at some level. Of course, if you want to use that model or those images in a varied way, you want to try and capture the variance or the variability, I should say, in the data that you collect. But this is a good place to start potentially. So the way I usually do it is by holding out my arm about 1.5 meters off the ground. For me, that's about shoulder height, and pointing the phone face down, being careful to avoid my shoes. One change I do make is that the phone cameras typically preference images that are too bright. And that means often the images are blurry because the shutter speed or how long it lets light come in to the camera is quite long because it wants to make the image quite bright. So if you decrease that target brightness, then the images can be much better quality. So I tend to click and hold on the image, and it locks the focus as well. And then you can drag down the brightness, at least on my Android phone. But head over to the weedrecognition.org, where you can find this image collection protocol, have a read through, collect some images, and then you can upload them and start annotating them on Roboflow. Once you have your images collected, the next part is to actually, I guess, use them and start annotating them. And these are some images. These are a subset. There's 15 image subset of a larger data set I collected in Denmark over some fields of wild radish in a winter ryegrass field. And so what we're, I guess, doing here is that protocol that I just told you about. And the idea is that I just walked out over the field, had my phone out at about shoulder height, and just took photos as I walked of any wild radish weeds that I could see. So the idea of what I want to do here now, as an example, is just annotate the wild radish only. Of course, there are many other weeds in these images, but if we stick to wild radish for this example, you can always extend it in the future. Here we'll start with wild radish, and we'll upload them through Roboflow and annotate them there. So these are my images. The next thing we want to do is head over to Roboflow. And Roboflow is, if you haven't come across it, is a fantastic platform and resource. They are a place that has, I guess, a whole lot of annotation tools. They have make it much easier to move and transfer your data in a range of different formats. So images come in one format, but annotations come in a whole range of different formats. Of course, you have PNGs and JPEGs and the whole lot, but annotation formats for bounding boxes, for object detection, have a range of different ways that they can be represented in data. So Roboflow makes it much easier to try and convert between them. They also have fantastic tutorials and resources on how to build your own models, or they just also released a new model called RFDTR that you can train. And there's fantastic, I guess, tutorials on how to annotate too. So definitely check out Roboflow. Once you've set up an account, you should get something looking like this, which is your projects page. This is one with a couple of other projects I've got, and the radish weeds that we'll be working on today. I've annotated 15 images already, but what we can do is upload the additional 15, and we can keep going with those. So once you have made a project, then you will find yourself on this page. In my case, I set up a object detection project because I wanted to label the weeds with bounding boxes, basically just drawing a box around each weed. But depending on your type of model you want to train or the scenario, you can change between, say, image classification or instance segmentation or some of the others. They've already had 15 uploaded and annotated, so let's upload the next 15. So I'll just select my images I showed you before, and I'll just drag and drop them into here. And they'll be uploaded, so they're the correct ones. And then we'll click Save and Continue. And then we're on the annotation part of the platform. So Roboflow offers a range of different options or methods of annotation. One is automatic, so you can actually prompt a large model to annotate, I guess, what you describe in the image. So we can give that a go. You can also do it manually, and sometimes that can be faster than this prompting, but we'll try this first, and then we can always correct it and then go back. So, and then also I think you can pay others to do it for you with human labelers. But with auto label and manual labeling, these have been worked fantastically for me. So let's try with auto label, see how it goes, and then move on with the manual labeling. So there are some instructions here. I'd recommend they're usually really helpful to go through. So this is a really good example of, you don't want to tell it to label all the wild radish or Raphanistrum because it doesn't necessarily know what the wild radish is. You're better off saying the leafy plant or the large broadleaf weed. Potentially that's too specific, but some of the best advice is potentially to keep iterating, as you would maybe with ChatGPT. Just keep trying until you get something that suits. Don't just use the class name itself. So probably worth watching that video. We'll get started, and we'll get rid of this class. We want the radish class, and the visual description should be large, leafy, green. Ooh, let's edit that. Large, leafy, green, weed. Save all, and then it'll do the auto labeling on the images. So nothing's come up with 50% confidence. So this is a confidence threshold. Depends how, I guess, confident the model is in this detection. But as we drop it, we'll probably start to get more annotations pop up. So this one didn't do super well. So I think let's try again. So leafy green plant with jagged edges. Save those. Let's see if that popped anything up. Yeah, again, not super well in this one. You can try a different image as well. It is getting some of the plants, but it's not doing particularly well on all of those. I think perhaps it does struggle often with agricultural and weeds settings. Sometimes it's good, other times not so good. So I might leave it for this time, but as they say in the instructions, it's worth playing around with these prompts. Sometimes you can get it to work quite well. But for 15 images, I'll probably just do it manually, and it might be just as quick. So to get out of this, we can just click back to annotate. This is the unassigned images. So these are the images we need to annotate. Here are 15 images. Click on annotate in the top right. Bring us back to this page. We want manual labeling this time. Assign them to me. You can also invite other team members to this platform as well, and they can help you. You can split them up, and you can work separately on the images, get each other to review them. It's quite useful for collaboration across teams. Assign to myself, and these are the ones now I have to do. So we can click Start Annotating in the top right, and get started. So these are some good tips as well to follow. Roboflow also have some good videos and walkthroughs that I'll link to in the description of this video on how to annotate different objects. And the key is to be consistent in what you annotate. So make sure you have strict rules that you follow or that your team follows, and always include the object and be very precise and consistently precise with how you annotate it. So label every relevant object in every image, even if it's partially visible. That's really good advice. Sometimes weeds are on the edge of an image and there might be one or two leaves present. So make sure you label those as the weed as well. Make sure the bounding boxes are really close in on the object, so don't create too much extra space. So less rubbish, I guess, or less background information there is, then the better a model can learn what your actual target plant or target object is. And this is, I guess, what I was talking about before, is your data must represent what and how you will use the model. So if you're using it, for example, with the phone and from this height, and particularly you want to deploy it for phone use, then this data set is probably okay if you're using it on particular weed, particular country, particular time of year, and particular crop setting. But if you were trying to use this, say, at a different camera, different angle, different country, and different crop, then even if it's the same weed, then the model is likely going to struggle a little bit. So that is probably just a general bit of advice to, yeah, it's a good thing to follow, to try and be representative as best as possible of how you use it. But any annotated data is better than no annotated data. So start somewhere, even if it isn't necessarily perfect, and then you can always improve from there. And that's the goal of WeedAI as well. If we all upload, say, 20 or 30 images that are annotated, then perhaps it's not enough for our own data sets, but together it can be a much greater resource for everyone. So with that said, let's get started into the annotation. I'll just go through, and looks like a couple of these have popped up. If you press D, it will bring up the sort of grabby tool. So I'll press D and delete these two boxes that have come up accidentally. Your other options are on the right here. So you have the bounding box tool. So if I press B for the bounding box, you'll see the image become clear again, and then you can start drawing a bounding box. I generally, when I look at an image, I try and divide it up into sections. So we want to be methodical about how we annotate. Sometimes you might miss a weed because it's difficult to see them. But in this case, to avoid that, you want to go maybe down one side and up the other, zoom in and then zoom out, and try and make sure you've got everything. So here's our first wild radish plant. We want to line it up nice and tight with the edges of the weed itself, and then draw and drag it over the plant. And that's our first one pretty much done. So you can see if we zoom in, and to toggle between zoom and scroll, I can press spacebar. Sorry, Control should do it. There we go. And you can see that it's probably actually a little bit wide on this plant here. So if we drag that in a little bit, a few pixels, it should be a little better annotation. So you want it as tight as possible around that plant. And then we can zoom back out and then go continue with our next annotation. Press enter to save that. Scroll down. And I think this plant here is our next one. So let's do that. The wild radish is quite clear in this example. Again, make sure it's really close to the edges of the weed. And that looks pretty good. And we can go on to the next. Making sure to check every corner so you don't miss any. Sometimes they can be hidden amongst either the crop. This is a overwinter ryegrass crop. There's also, of course, a lot of weeds, other weeds here. So some clovers and chamomile, I think, potentially. They're not particularly the best at Danish weeds. That's the one we've already done. And it looks like there's one on the edge here. So if we save our previous one, zoom in on here, and we can annotate this as well. And that looks like I think most have been done. I generally like to zoom out again and take a different perspective, scroll at a different angle to make sure I have actually annotated them all. That looks correct. So we have 3 for this image, and then we move on to the next. So I'll fast forward over this. You can of course slow it down if you want to see how I annotate, and then I'll jump in with you at the end of these 15 images. Hopefully shouldn't take too long. So one rule I will point out here is that when I'm annotating and there are 2 weeds that are really close to each other, so in this example, you can see there's the large weed here, and then behind it, there's actually a separate weed that overlaps with the big one. In this case, it's quite clear where they differ, as in which leaves belong to which plant. But often if there is no clear distinction which leaves belong to which plant, and it looks like one mass of wild radish or one mass of a particular weed, then you're better off annotating that whole cluster as a weed itself, at least in my experience. Because otherwise the model can then, if it's given unclear examples about which the objectness or how a weed as an individual looks, because in some cases it's got all these leaves going from every direction because an arbitrary box has been drawn around a large cluster, then it won't necessarily train as well as if you give it really clear distinctions around this is just a cluster of a weed, this is a plant. And so I think, in my experience at least, it could be wrong, but the best way is if there is a clear distinction between plants, then draw boxes around them. If there is just a mass and you know there are multiple plants in there, but you can't see distinctly which leaves belong to which plant, then just annotate the whole mass as that weed. At least that's helped me. But yeah, I'd be interested in hearing anyone's opinion on it, but that's been my experience in the past. So in this case, I'll just label these two because they look quite clearly different. All right, so that's been checked over. So now we can go back to our dataset page. These are all annotated. You can see the annotations in the preview images. And what we can do is go back to the dataset, the annotation page, and we can add these 15 images I've done previously to the dataset. And then you can select your test and training split. So this is just a Roboflow thing, because when you export it to, say, train in Google Colab or use another in other platforms, then it'll partition the data set into different test, train, and validation splits. But because we're just uploading this to WeedAI, it's not so important. But we'll just go add images, and then we can go annotate again, and then we'll add these 15 as well. Great, so our data set now has 30 images. So the 15 we annotated just now and the 15 from before. And we can start to do things like look at the analytics. So this will show us, once it loads, how many total number of annotations we have for these 30 images, the different image sizes we have. So there are a different proportion of wide and tall images from different, I think, camera configurations. It also shows us where the annotations are. So this is quite an interesting way of looking at potential bias in your data set, because when you take images of a weed, there's probably a bias, at least for me, where I tend to center the weed in the image. And so you can see here that there probably is some sort of bias creeping in, where the weeds are often in that center or up to the top right. So something to be aware of, at least when you collect data in the future. You can see how many annotations there are per image on average. So there's generally about 2 to 3, and you can see the averages up here, 2.8 per image on average across those 30 images. Not too bad, almost got 100 weeds, but now that's basically ready to upload. So what we can do now is go to our versions. If we go to classes and tags, actually we probably should remove, so we modify classes, and we don't want the weeds class, so we can apply changes to delete this. So there's no labels to double check, because if you do delete it, there are labels, you will lose those labels. Now all we have are the radish with an 84 count. So we go to versions, and what we can do now with our 30 images is create a new version. What you want to be careful to, though, is not include any pre-processing steps. So with Roboflow, they have these functions to change image size or add augmentation strategies, which is probably not the greatest thing I like about Roboflow, because to me, you want just the original data sets, and they do keep versions of this, but at least, yeah, I think you can do this if you'd like, but often it's better to do it at the training time itself, as opposed to actually creating the data set with those augmentations already. So we'll remove this resize because we want to keep the whole image size, the original one. Auto orient is useful though, because it makes sure all the images are in a particular direction, and it removes that orientation metadata when we upload it. So this is all fine. Press continue. Augmentation, we don't want any of those. And now we can create. All right, so now this is done. This is your dataset card for version 1. And what you can do is keep iterating on this and building and increasing the number as you get more images in. You can train models at this point on this version and then use that version's model to then iterate on new data you bring in too. So it's quite useful in that sense. But in this case, we do just want to download this dataset for WeedAI. Selective format. This is probably the most important part because there's a whole range of different ones to choose from. WeedAI accepts Cocoa and also Pascal VOC. I prefer Pascal VOC just because it has an individual annotation file associated with every image. So you have like a nice pairing, whereas Cocoa is one annotation file for every image in the dataset. Same thing, some models use Cocoa, some use Pascal VOC. Of course, lots of the YOLO ones these days use the YOLO format. But let's stick with Pascal VOC, and what we'll do is download the zip to the computer. So I've just gone ahead and extracted this, downloaded and extracted the download. So you should end up with something looking a little bit like this, where we talked about the train, test, and validation splits. If you keep it all as train, if much easier because then you just have a single directory with all your XML files. This is your annotation, and this is the image that's associated with. What you do want to do now is just sort these into annotation and image folders so we can more easily upload it to WeedAI. So we'll call this ands and images. And if we sort by type, great. And so now we're getting pretty close to the point of upload. So what we now need to do, I'll just drag this down here. We'll head over to WeedAI. So now for the exciting part. You've gone through the annotation, which can be a little bit of a hassle sometimes. But this part now you get to share it up on WeedAI and let others potentially use it or contribute to it and make the most of your work. So this is the main page. This is where you can search for data sets. But if you head over to the upload page, you'll be able to start this process. So you'll log in first. Usually Google account is probably the best way of doing it. And then once you've logged in, you should appear with this begin upload option. We want to choose Pascal VOC for ours, but you can of course choose some of these others if they suit you. And now we can drag and drop those annotation files that we just sorted then. So I'll just drag those in here, all 30 of them, and you'll see them slowly upload. If there are thousands, for example, if you're uploading a very large data set, this can take a little bit of time. So just be patient and let it crunch away in the background without clicking outside of the box. Press submit, and then once they're submitted, click next. Again, can take a little bit of time if you do have a bigger data set. And this will bring you to the weed categories page where we map our classes that we gave it in Roboflow, so the radish class, we map it to an actual species name or a particular crop. So in this case, radish is a weed, but if we had labeled the crop as well, we can also designate that here. So weed class, and then we can specify our species. So for us, it's the Raphanus Raphanistrum, which is wild radish. This is the genus is usually capitalized, but for our platform, you have to have everything lowercase. Unspecified if you don't know, or if it's a general weeds class. Otherwise, you can actually include higher order classifications, so things like family or genus by itself. And that will just, for example, if you just had Parma amaranth, but you only want to annotate it at the Amaranthaceae family, then you can just put Amaranthaceae down, and then it'll just appear in those searchable formats as only Amaranthaceae as opposed to Parma amaranth, if you didn't know. If you do know, of course, it's best to put exactly what it is. Subcategories are reserved for things like plant parts. So say we'd only annotated the flowers, the leaves, the stems, or particular growing points of the wild radish or the weed, or if we had things like growth stages or other information you'd like people to realize out of this. But for us, we just annotated the weed, so it's quite straightforward. So we click next, And this will bring us to probably the biggest bit of work for it, which is the ag context. But if we do this now, then other people can search and make the most of this data, and it's in a standardized format, so we can compute it going back, I guess, if we want to sort of look over this data set or group data sets, we can group them by particular properties. So this basically includes all the agricultural information that might make this more relevant, as well as photographic information, so things like the camera and what we saw previously. So to start off, we need to say what type of crop it's in. If it isn't a crop at all, this is a list that was developed with the platform. The crop we have, which is an overwinter ryegrass, isn't there. So if we click on other crop, or if it's in a fallow, we can actually say not in crop or in some sort of pasture. So in our case, it's a winter ryegrass, which is Lolium gren. Otherwise, you could type in, of course, something else. The crop growth stage was very early tillering. So I often use the BBC, or this uses the BBCH growth stage scale, as it says down here. So the tillering stages are from 2 to 3. Let's Google that. BBCH scale. There we go. So that's correct. So leaf development, basically for people who haven't used it before, the BBCH scale is a way of categorizing the growth stages of different plants. It's often used in wheat or in crops, so you can determine how old the plant is on a much more standardized fashion. So for example, the ryegrass we saw, you can see it only had some tillers. In the background here. So if we look at it closely, we can see there's maybe 1 to 2 tillers. So a tiller is the number of sort of offshoots or side shoots coming off the main stem. So I'd say this is probably maybe a 2-3, a 2-2 stage. It's still fairly young, but it does have quite a few leaves and has matured somewhat. So yeah, I'd say maybe 2-2 or 2-3. Some of them are probably even like 1-8. So what we can do is then go back to the growth stage range just here, and the minimum was probably, I think, about 1-7 with about 7 leaves. Again, it's an estimate because of course you can't count the leaves on every plant, and the maximum was some that I think had about 3 tillers. So we'll say 2-3 was the maximum. But just do your best guess at what there is. It does mean that if you are collecting across a large range of plants across the season, then this would be, of course, from all the way from 0 to maybe not 0 if it hasn't emerged yet, but from say 10 all the way up to pre-harvest. I find it's best or easiest just to consult either Wikipedia or the particular growth stage range for your crop. So for example, if we go to, if there's a grass here, maize is not too bad, relatively similar at least. But we can see that, yeah, two leaves unfolded, 3 leaves all the way up to 9 or more leaves, no tillers beginning 2, 3, etc. So I think around 2, 3, 1, 7 is probably about right. Okay, so going back to the ag context, the soil color, we can see it's sort of a light brown, gray soil color. So the drop downs give us probably a gray, I think, is the best description. The surface cover is effectively none from what we can see. This was plowed prior to planting, and I'd say there's very minimal actual surface cover on any of these. Surface cover could be things like large amounts of stubble from a previous crop, or if it's in a crop, of course, there wouldn't be any cover. It's just the underlying crop itself. In plastic culture or some horticultural crops, there'll be the black plastic or white plastic. Perhaps there's cotton that's come off the back of a harvester, or different types of things, like you might have a legume previously. So perhaps you had lupins, or you might have had some beans, and then you're planting wheat now. We have weeds coming up through that. That's where you might change it around. And canola stubble looks very different to, say, cereal stubble. But I think for us, it'll be none. The service coverage is effectively NA because we don't have any. And this is the location of the data and where it's collected. I find the easiest way is just to go to Google Maps and you can click on a location and copy the location's coordinates. So I've used these coordinates here. Best to just approximate, I guess, where it was collected. And we can just paste them in. So that will be, of course, the whole lot. And then we can just go double check what that was. 153 and then 12. We'll just copy the second number. And it needs to be in decimal degrees as well, so in this format. So that's the first page done. Now it's for the photography. The camera make is a Samsung S21. If you go to and right click on the image and then click properties, it will give you the actual specifications of the camera on which it's collected. If you allow that to be collected on your phone, it's quite useful when you go back through it. But of course, you have to be careful about sharing your metadata. But if you go here, the camera model is an SMG991B, so we can copy that in. The lens is just the S21 lens, but it has a focal length of 5 millimeters. So the focal length is 5 millimeters. This will tell you either on the camera you're using or the lens you're using, I should say. The camera height was approximately 1500 millimeters. The angle was pointing straight down. So a camera facing straight down would be 90 degrees. If it was facing forward, it would be 0. The specific field of view is a slightly more complicated one. It is basically the diagonal across the image itself, I guess. So it's a function of the sensor size, the lens characteristics, and it gives you an understanding of the on-ground footprint of the image, essentially. Because once you have the height plus the diagonal field of view, then you can figure out exactly how large the image covers, or the area it covers on the ground. So for this one, I've calculated it as 67.8 degrees. You can Google, and there are a range of other websites that provide the calculation for you based on the sensor properties. I'll leave those links as well in the description. Ground speed is 0 meters per second. So that's just if you have a robot that's moving continuously or a drone potentially. For us, or each time I collected it, it was just walking and stopping and taking a photo. The lighting was entirely natural, but of course, if you have a light, then it will be artificial. Photography, images. This is where you just want to describe the general collection method. Then other details, the weather description, so overcast, weather, no sunlight, dark conditions. And that's effectively everything now. So very important if you want to save this. So this is basically a JSON as a type of file format you can then reference in the future. Or if you've done this previously, you can drag and drop it into here. So this one I'm going to download, save, and then go cancel. But say if you've done this or something went wrong, you can come back here and drag and drop that JSON file back in. Next is almost the final step. So we need to give this a dataset name. So I'll call this Danish radish weeds. And this is a description of the dataset. So you can see your license by default has to be CC by 4.0. Date published is today, 7th of April. And this is where you can add the authors and creators. So for me, it's just me for this one. And the organization is through the University of Copenhagen. And that is everything for that one. So you can go referencing if you have grants or other, say, GitHub repository associated with it, or funding organizations here too. So it may be more useful if you're a university to fill out these parts. But I'm pretty happy with that. So we can click next. Now for the final step is the upload of the images. Here you can just either select the image files themselves, so the ones we downloaded from Roboflow, or we can go through and actually create a zip file and upload the zip file of the images. Zip file is probably easier for larger data sets, so maybe above 50 images. Otherwise, just navigating to the images we downloaded from Roboflow. So they have to have the same name as the Pascal VOC, so make sure you select those, not the originals. That's probably easier or fine for these 30. So if we select choose images, navigate to this image set here, images, select our 30, select open, and then after some time they should upload. There we go. All right, so now our image is uploaded. Sometimes you don't select them all, or you might have one left. You can click and see the which one it is, and then upload that specifically. So press submit, and that's effectively done. So you can watch this data should change to processing, and after it's been processed and checked to make sure there are no errors, so things like duplicate images or annotations that haven't been correctly or too small, or haven't been deleted or don't exist, or other sorts of errors like that, you'll receive an error message here. If it's been accepted and processed and there are no errors, then you'll get awaiting review. And that's when one of us will look at the images, make sure that it's good quality annotations, let you know if any changes need to be made, and then click review as needed. And there you go. So once that's been reviewed, approved, then it has been successfully uploaded to WeedAI, and you've now contributed to the growing repository of images that anyone can access. You should receive some emails giving you confirmation of that as well. So to see it, of course, that's the next important thing. What we can do is come over here. We want to search for our lolly and paren. These are our 30 images. Now we can filter by these images, and we can see our hard work in action. So you can see all these images that we labeled with the Roboflow platform. And if we click on them, you can see the taxonomy of the weed itself, Raphanus raphanistrum. You can click on see dataset. And this will take us to the Danish winter radish weeds. And you can see how many bounding boxes we have, 84, 30 images, the crop it's in, lolly and paren, our 17 to 23 BBCH scale, location, surface coverage, etc. Everything you need. And that's ready to go. So that's pretty much it. You can, of course, then find any data sets that you'd like to have a look at or check out, and then download them. So we can see this one here, and then download in WeCoco format and start integrating that into your own models. But that's it for this tutorial. Thanks very much for following along. I really appreciate the interest in the project as well. Feel free to get in touch if you have any questions. And until next time, enjoy the annotating, enjoy the uploading, and hope to see you again. Cheers.